Hello students, as in the last lecture we had completed the type number 7 which was based on integration by part, that is integration u into v. I hope you all understood to which section we have to consider u and to which part we have to consider v. Okay, so according to the selection of the alphabet, as I had given one alphabet, that is LIT. With respect to that, first come first. L stand for logarithm, I stand for inverse, A stand for algebraical, T stand for trigo, and E stand for exponential. With respect to the arrangement of the letter, with respect to that you have to consider U and V. So today we're gonna see the type number 8, which is based on one property. Type number 8, which is based on one property, that is integration e raised to x f of x plus f dash x dx is equal to e raised to x into f of x plus c. So what is the formula? Once again I will explain. Integration e raised to x should be there, then inside the bracket you must have the two function, and it should be separated by plus, then it is equals to what? E raised to x into f of x plus c. So this formula I can say it look like, okay, it look like not exact similar, f dash x upon f of x into dx, that is log mod of f of x plus c. Yes or no? So in this property what we used to do, we used to consider the denominator as f of x, and we used to find the derivative of the denominator. If derivative of denominator is exactly equal to the numerator, then only we used to apply this formula, f dash x upon f of x is equals to log mod f of x plus c. Similarly here also, okay, one section will be f of x and second section will be f dash x. Now it is not compulsory that the first, always the first part will be f of x and the second part will be f dash x. Okay, sometimes the arrangement will be different. Sometimes the second part will be f of x and the first part it will be f dash x. Now here you have to consider f of x to that term for which the derivative is perfect. Okay, once again I will explain. You have to consider the f of x to that section whose derivative comes. Like here if I say derivative of sine is what? Cos. And derivative of cos is what? Minus sine. So which one is perfect? Sine is exactly equal to cos, or cos it is exactly equal to minus sine. So here clearly we can see that sine perfect derivative is cos. Here no need of doing any adjustment. Straight away we can consider this first part as f of x and second part as f dash x. Yes or no? So it is on you to consider which section as f of x. So it is very important part. Okay, you must know to which section we have to consider f of x and which part we have to consider as f dash x. See to it that you have to consider f of x to those term whose derivative is perfect. Like here for log x and 1 upon x, derivative of log x is 1 by x. 1 by x derivative it is not log x. So common sense here, f of x will be what? Log x, and its derivative is 1 by x. What do you mean by f dash x? F dash x means what? Derivative of f of x. So the important thing for this type is the selection of f of x. If select the f of x perfectly, then the rest part it is very simple. Like here also, the derivative of 1 upon x is directly minus 1 upon x square. Yes or no? If one part is f of x and second part is the derivative of that part, yes or no? Suppose if you consider this part as f of x, if derivative of this section is perfect, then only we can apply this formula. At the formula it says that e raised to x f of x f dash x is equals to e raised to f of x plus c, and see to that e raised to x, it should be outside the box, and here the power it should be x only. If it contain any other term than x, then you have to consider this part as let. Okay, like suppose if I say in place of x, if it is e raised to sine or anything something else, so you will consider this part as t. So in the next step it will be e raised to t. Okay, got the point? So if it is e raised to t, so the whole section it will get converted into what? T only. So let's take some few examples, then only you will come to know exactly how to apply the property. So here we have the first example, that is I equals to integral e raised to x sin x plus cos x. Okay, so here we'll put f of x as sin x, yes or no? Because derivative, the perfect derivative of sin x is cos. If we consider cos as f of x, so derivative of cos will be what? Minus. So here you have to adjust the minus sign, all that. Okay, and after adjustment also it should match with the previous step. Okay, so why to do all this unnecessary things? So clearly we can see that for this sum the perfect derivative is what? Sine is the derivative of sine is cos. So for sine we'll consider as f of x, and its derivative will be what? Cos x. Yes or no? So clearly we can see that this look like this formula. If we replace the sine x by f of x and cos x by f dash x, so it is equal to what? E raised to x into f of x plus c. So here you will mention the formula as this look like what? Integral e raised to x f of x plus f dash x into dx, which is equals to e raised to x into f of x plus c. So therefore e raised to x will be e raised to x. What is there in place of f of x? It is sin x. So e raised to x into sin x plus c is the final answer. Okay, and there is one more method. The second method is what? Just simply bracket open. So here you will get what? E raised to x into sin x plus e raised to x into cos x into dx. As there are two terms, so we can separate the integral also. So integral e raised to x into sin x into dx plus e raised to x into cos x into dx. Simply apply u into v here. Here also u into v. Okay, you have to consider the first come first according to this alphabet LIATE, as trig of come first and then exponential. So this will be u and this will be v. For this section also this will be u and this will be v. Apply u into v here, and here also some common term you will get, cancel that section. So you will left with, at the end you will left with what? E raised to x into sin x plus c. So for this sum there are two different methods. If you want to solve this sum by using property, so you have to mention the property and then straight away you can write the answer, or else bracket open with this e raised to x, where you will get two sections, then apply u into v for the first part, and even for the second part also u into v. Some common term you will get, cancel that common term, and the final answer will be what? Same as it is, e raised to x into sin x plus c. Okay, if you want to try this sum by this method, you can try by yourself. Okay, but I will suggest whenever you come across, if you see e raised to x outside the box and there are two different term, okay, and it is connected with plus or minus, e raised to x, if it is outside the box and integral is there, straight away try to apply this formula and consider f of x for the one part and f dash x for the second part. So let's move on to the second sum. Your second one is what? I equals to integral e raised to x log x plus 1 upon x. So we'll put, as I told, you have to consider f of x to that section whose derivative is perfect. So here clearly we can see that log x derivative is 1 upon x. 1 upon x derivative, it is not log x. So here we'll put log x as f of x, okay? Or we can write as f of x is equals to what? Log x. Its derivative f dash x will be equals to what? 1 by x. Okay. So therefore, using the property that is I equals to integral e raised to f of x plus f dash x into dx. So we know that the answer is e raised to x f of x plus c. So here e raised to x will be e raised to x. Here f of x is replaced by what? Log x. So the final answer will be e raised to x into log x plus c. So in this way you will find your answer. That's it. I hope you all understood the property, how to use, how to apply, and how to frame the steps. Okay. So let's move on to the third example. For this, first we'll check to which part we have to consider f of x. As clearly we can see that derivative of f1 1 upon x is minus 1 upon x square. For minus 1 upon x square, derivative will be different, yes or no? So here clearly we can see that derivative of 1 upon x, it will be what? Minus 1 upon x square. So this part will consider as f of x and this section as f dash x. See that in every question they will not give the arrangement like this directly. The first part will be f of x and the second part will be f dash x. There are many sums in the exercise where you will see the second part sometime it will be f of x and the first part will be f dash x. So that perfect guessing you must know to which section you have to consider f of x and to which part you have to consider f dash x. So here again same, we'll apply the property. So what is the property? That is e raised to x f of x plus f dash x into dx, it is equals to what? E raised to x into f of x plus c. So e raised to x into f of x is what? That is 1 by x plus c. So here we can say the answer is e raised to x into 1 upon x plus c. Okay, I hope you understood all these three sums. So let's move on to the next few sums based on the type number 8 only. Now here the next one is what? I equals to integration e raised to x upon x plus 1 the whole square into dx. As I told how to guess the property, it is very simple. Whenever you come across e raised to x, integration e raised to x, and inside the box something it is there and then dx it is there, simply you will apply this property e raised to x f of x plus f dash x plus c. But here when you will see here we have only a single term. Okay, as I told, there should be a two separate term and it should be separated by what? Plus or minus. So the first part will be f of x, the second part will be f dash x, or the second part will be f of x, so the first part will be f dash x. And see to that this two term it should be separated by plus or minus. As clearly we can see that here we have only one term which is in the form of u by v. As we know that in integration we don't have u by v section. Now we have to break this u by v in a such a way that we must get two term and this two term it should be separated by plus and minus. So let's move on. So first of all we have to do this adjustment. We have to separate this, we have to break this u into v in this format where we must get two terms and this two term it should be separated by plus or minus. Now see the adjustment what I am doing here. As here we have x, yes or no? What is there with x? It is plus 1. So here I will do this adjustment plus 1 and minus 1. See the first step. I hope you all understood. If here it is 2, so you will write plus 2 minus 2. If here it is plus 3, you will write plus 3 and minus 3. So this property, this method, it is only applicable when this x are same, and here it is the whole square. Remember this, okay? Suppose here it is x square and here it is x, so we cannot apply this x part, it should be same. And then see what is there with this x, it is plus 1, so here you will write plus 1 and minus 1. If you cut this plus 1 and minus 1, you will get the previous step. Okay, so see to that whatever the adjustment you will be doing, okay, it should match with the previous step also. Now after this e raised to x, we'll consider this x plus 1 as one section, the second part x plus 1 the whole square into dx. As I told, we have to break this u by v in this section. You have to break this u by v in a such a way that this two part it should be separated by plus or minus. Okay, so now we'll separate the denominator. So x plus 1 upon x plus 1 the whole square minus 1 upon x plus 1 the whole square. As clearly we can see that we had converted this step into this format. As I told, you must get two part, and this two part it should be separated by plus or minus. Okay, so now in the next step, as clearly we can see that x plus 1, here 1 x plus 1 will get cancelled, so here we left with 1 upon x plus 1 minus 1 upon x plus 1 the whole square. I hope you all understood the adjustment till here. Okay, now as per the rule, we know that we have to apply the property. So out of this two section, the first part will be f of x and the second part will be f dash x. So now we have to consider which part is f of x and which part is f dash x. If we consider this first section as f of x, when you will find the derivative of this part, derivative by using derivative of u by v, you will get this answer. So let's see. So we'll consider this part as f of x. So f of x is 1 upon x plus s, x plus 1. Okay, now consider this x plus 1 as this whole term as x. If you consider this whole section as x, so what is 1 upon x derivative? It is minus 1 upon x square. But here in place of x, it is what? X plus 1. So answer will be what? Minus 1 upon x plus 1 the whole square. But here x is replaced by some other term. So we have to find the derivative of that part also using the chain rule. Here you will get the answer what? Derivative of x is 1 and derivative of 1 is what? 0. So here the final answer will be minus 1 upon x plus 1 the whole square. So straight away here we can see that derivative of 1 upon x, actually it is equals to what? Minus 1 upon x plus 1 the whole square. Okay, I hope you all understood this adjustment. Okay, once again I will explain. As the format, it is in the form of u by v, and outside the box clearly we can see that e raised to x is there. So common sense, whenever you come across e raised to x outside the box, so you have to apply the property e raised to x f of x plus f dash x plus c. So we have to convert this u by v section into in this part in a such a way that you must get two term, and that two term it should be two function, and this two function it should be separated by plus or minus. So here I did this adjustment. Just simply you have to check here what it is there. If it is plus 1, so you will write plus 1 minus 1. If it is plus 2, you will write plus 2 and minus 2. Okay, then separate this term, separate the denominator. As here one part it will get cancelled, here you will left with 1 upon x plus 1. So when you will check, you will find the derivative of this part, you will get exactly minus 1 upon x plus 1 the whole square. So this is f of x and this is f dash x. So therefore I equals to e raised to f of x plus f dash x into dx. It will be equals to e raised to f of x plus c. So therefore e raised to, what is there in place of f of x? That is 1 upon x plus 1 plus 1 plus c. That's the end of the sum. I hope you all understood the method, the process. If it is not in the form of f dash x and f of x and f dash x, you have to do this adjustment first and then you have to consider f of x and f dash x. I hope you understood all the four example based on the type number 8, which is e raised to x f of x plus f dash x into dx, it is equals to e raised to f of x plus c. Okay. Okay, so let's see the next example. As here we have I equals to integration e raised to x upon x. Then inside we have x into log x the whole square plus 2 into log x. As per the rule, as per the formula, here we require only e raised to x. Okay, it should be e raised to x outside the box. As here we have e raised to x upon x also. So with respect to the formula, will bring this x inside the box. That means we'll bracket open with this x. Okay, as this x is in the denominator, so in simple language we'll bracket open with 1 by, here nothing is there, so we can consider 1 by x. So simply bracket open with this 1 by x term into dx, because we know that here we required only e raised to x. Okay, with e raised to x, that should not have any other term. So whenever we have any other term, just simply bring that term inside the box. Okay, so the next step, your x will get cancelled, so you will be left with log x the whole square plus 2 into log x upon x. Okay, so here little confusion is there, so now we have to guess which section we have to consider f of x and to which part we have to consider f dash x. Okay, suppose if we consider this part as f of x, so let's see, f of x equals to log x the whole square. So what will be f dash x? As this look like the formula of what? X raised to n. So what is the formula? N into x raised to n minus 1. But here x is replaced by what? Log x. So here we have to apply the chain rule. So first we'll apply the x raised to n formula. So 2 into log x raised to 2 minus 1. But here x is replaced by log x. So we have to apply the chain rule also. Yes or no? So 2 into log x, 2 minus 1, it is 1. And derivative of log x is what? 1 by x. Yes or no? So you must know the basic, at least the basic derivative and the chain rule also. Okay, so 2 into, I hope you all might be knowing the chain rule how to apply. Okay, so 2 into log x upon x. So you clearly we can see that as we took this as f of x, so here we got 2 into log x upon x. So this part will be f of x and this part will be f dash x of f of x. Yes or no? So here we come to the conclusion that this look like e raised to x f of x plus f dash x into dx, it will be equals to e raised to x into f of x plus c. Yes or no? I hope you all understood the adjustment and how to frame the step for the exam. So e raised to x into, so what is there in place of f of x? It is log x the whole square plus c. Okay, so don't write this part as this is not f of x. After the adjustment, you come to the conclusion that this is f of x and this is f dash x. So I hope you understood all the 5 sums which we had did today. Okay, based on the type number 8. So let's move on to some few more example. Okay, so let's move on to the next one. As here we have I equals to integration e raised to sine inverse. Inside the box here we have the format which is in the form of u by v. So we know that we have to split this u by v in such a way that inside the box you must get two function. So here the first part we'll consider as f of x and the second part as f dash x, or vice versa, second part as f of x and the first part as f dash x. Okay, and here it should be e raised to x. So here x is replaced by some other term. It has to be e raised to x only, yes or no, or e raised to t if we put t. Okay, so here the first step will be what? Here we have to convert this part as, we have to consider this part as t, because as I told, it should be e raised to x, or x should be replaced by t. If x is replaced by t, so this whole section will get converted in terms of t only. Okay, remember this part. Here it should be e raised to x. X should not replace by any other term. If it is replaced by any other term, see to that you will consider that section as t. So we'll see first. We'll put, first we'll do this adjustment. We'll separate this denominator section, x upon root 1 minus x square, yes or no, x upon root 1 minus x square plus root 1 minus x square upon root 1 minus x square into dx. Okay, as you can convert this u by v into in this section also, plus minus. Okay, two different term. But when you do this adjustment, your difficulty is what? Okay, this part will get cancelled, you will get 1, and you have to check whether the derivative of this part is exactly equal to this or not. Okay, so there is one more method for this sum. Directly you can start with what? Put sine inverse x equals to t. If you do this adjustment, because as I told, whenever it is in the form of u by v, try to separate the term in a such a way that you must get two function. As clearly we can see that here we have only one denominator, so we can separate the denominator. But after separation, okay, you will end up with getting the wrong answer, because as this part will get cancelled, as I told, this section should be what? It should replace by x or t. Okay, x or t. So this whole part will get converted into t only. So first step will be what? First we'll convert this whole section into t, and then we'll separate this denominator. Okay, so let's check. So first we'll consider this part as t. So derivative with respect to x will be what? Derivative of sine inverse will be what? 1 upon root 1 minus x square equals to dt upon dx. So we'll bring this dx to the left hand side. So here this will be what? 1 upon root 1 minus x square into dx equals to dt. Okay, so here in place of sine inverse we'll write t. Yes or no? Okay, now listen here. Can I separate this term as like this? First we'll write the same question, then after that I will explain. Into 1 upon root 1 minus x square into dx. Can I write this section as like this? E raised to sine inverse, then separate this part separately, write this part separately. So when you will multiply this part, you will get this same step, yes or no? So why I did this step? Just to explain this step properly. So if you replace the sine inverse by t, okay, sine inverse by t, and 1 upon root 1 minus x square into dx will be what? Dt. So this will be what? T, and this part will be what? Dt. As I told, as we took t here, so this whole section it should get convert into t part only. So here we require the answer of x also in terms of t. So listen here, how you will find the value of x here. Simply shift this sine inverse to the right hand side. So this, when you will shift this sine inverse to the right hand side, so this will be x equals to sine t. Yes or no? Here we got the value of x. So simply substitute the value of x here. This will be sine t. As per the rule, as I told, if you consider the sine inverse as t, the whole section it should get converted into the same alphabet. Okay, with respect to t only. And in the final answer, we have to find the integration with respect to t only. Okay, so here we'll substitute the value of x by sine t. Here also we'll replace x by sine t, but here we have sine x square, so this will be sine square t. In the next step, this will be e raised to t as it is. We'll keep sine t also, and we know that 1 minus sine square t, using the identity property, it is cos square t. Yes or no? In the next step, e raised to t sine t plus square root will get cancelled, so here we left with cos t into dt. I hope you all understood the adjustment section, how we had did the adjustment for this sum. As I told, here we required only e raised to x. Okay, here x should not be replaced by any other term. If you see x is replaced by any other term, or e raised to x, it is not there, so we have to take let. Okay, so here I put sine inverse as t. So if you put sine inverse at t, see to that this whole function it should get converted into t term only. So here, after replacing all the values, here we left with x. As I told, this whole section it should get converted into t. Even this x part also it should be in terms of t. So here we got the value of x also. Simply shift this sine inverse to the right hand side, so here you will get x equals to sine t. So after replacing the value of x by sine t, so here we got 1 minus sine square. As we know that identity formula, it says that 1 minus sine square is equals to cos square t. So here square root will get cancelled. So here we left with sine ti plus cos t. As clearly we can see that we had converted this full whole sum into your first sum. As the first sum, it was like this only, e raised to x sin x and cos x, but here just x is replaced by what? T. Here we had integrated with respect to x, so here we have to integrate with respect to t. That's it. So here we'll consider this section as f of x and this part as f dash x. Okay, but here we have alphabet t, so we'll consider f of t. First check derivative of sine is perfect or derivative of cos is perfect. Derivative of sine is what? Cos, and derivative of cos is minus sine. So here we don't have the minus sign. So we'll consider this as f of x and this as f of f dash x. But the whole section it is in t term. So here the function will be with respect to t only. So we'll take f of x in place of f of x. We can write as f of t. So f of t will take sine t. So its derivative with respect to t will be what? Minus cos, sorry, it will be what? Cos t. So we'll apply the property. Okay, so what is the property? E raised to t, because as here we are integrating with respect to t, so here of course we'll take e raised to t only. F of t plus f dash t into dt will be equals to what? E raised to t into f of t plus c. So here clearly we can see that e raised to t will be same as it is. F of t is replaced by what? Sine t plus c. Okay, so this is not the final step. We have to replace the value of t. That means we have to resubstitute the value also. So here t is what? When you will resubstitute the value, t will be what? Sine inverse of x into sine, and t will be what? Sine inverse of x plus c. So therefore e raised to sine inverse of x, the sine and sine will get cancelled by using the property. Yes or no? By using this property, inverse property as sine will get cancelled. Here you will left with what? X only. So that's the end of the sum. So I hope you all understood this sum. So in this way you have to present your sum whenever the x is replaced by any other term. Okay. So I hope you all understood all the example, as I took almost more than 4-5 example for e raised to x. Okay, so in the next video we'll see some few more example based on this let method only. We'll see if x is replaced by some other term, or if e raised to x, if it is not there only. So how we have to convert that whole section into this formula. So in the next video we'll take some few more example based on type number 8. Till then, goodbye, see you in next lecture.